Hello everyone, welcome to my channel. This is day one of our crash course, and today we are starting with the gravitation. Um, yes, this is chapter one, which we are starting with. So, welcome you all, and all the best for our crash course. So, here we go. Chapter one, which is gravitation. So, I have picked up some important definitions for you all, and I'll be explaining this important concept first of all. So, the definition number one, which is gravitation. Definition one, which is gravitation. Then we'll move on to the gravitational force, that how the gravity is measured in the terms of force. Then the Newton's universal law of gravitation. Then circular motion and centripetal force. The most important Kepler's law, according to the exam point of view. Then moving on to the acceleration to the gravity, mass and weight, and free fall. And some more important concept will be there, like escape velocity and uh, anything else. Okay, so I hope you have prepared for gravitation already, but I'll make sure to complete and cover all of the important points here. Okay, okay. So starting with what is gravitation? What is gravitation? What is gravitation? The gravitation is the force by which any two objects in the universe attract each other. Whenever there is some force which is pulling the things towards itself, that force is a gravitation. So I have drawn the mathematical expression and mathematical terms for the gravitation. This is m1 and this is m2. This is nothing but the mass of object 1 and mass of object 2, and these objects are pulling each other towards themselves, and they are kept apart from with the distance which is r. Okay, so whenever there is a force of attraction between the mass 1 and mass 2, then what happens? It is the force between the two objects which are pulling together towards each other, and the force between them is directly proportional. Force between them is directly proportional to the mass of these objects. What does it implies? This implies that the force, the gravitational force which is there between the two objects, it will be directly proportional to the product of these masses. What does it mean? The larger the mass of the objects, the more it will hold the things together. Okay, higher the mass, stronger the gravitational force, stronger the force of attraction between these two objects, and it is inversely proportional to the square of radius or square of distance between them. This r is not a radius, but this is the distance between them. Okay, so what does it mean? R square. So if the objects and the objects which are there, and the gravitational force will be the inversely proportional. It means if the objects are kept apart from each other, there won't be the stronger gravitational force as compared to the instance where the things are kept together. So, as the things will move apart from each other, the gravitational force between them will weaken, or it will be inversely proportional. What does it mean? If the force will decrease, the gravitational force will decrease when the distance increases. Okay, yes. So, that was the that was the proportionality constant. That was the terms of proportionality between the masses of the product and about the distance between them. Okay, and the proportionality, the symbol of the proportionality is replaced by the gravitational constant. Okay, so g is the gravitational constant. Okay, and the value for the g will does not change anywhere on the earth. Wait a minute. Okay, so moving on to the next concept, which is Newton's law of gravitation. So, as we all know that Newton, Sir Isaac Newton, was the first one who has Sir Isaac Newton was the first one who has discovered the Newton's law of gravitation, the law of gravitation, and we all know what the instance behind it. So we all remember the instance when he was sitting under the tree and the apple fell down on his head, and he then just he just got curious that how does the apple fall down only vertically downward, and why didn't it flew away anywhere else, or why didn't it go upward? Why does it fall down only vertically downward toward the earth, toward the surface of the earth? So that was the instance that got him into the question about this force which pulls the things toward himself, not toward himself, but toward the earth and toward the surface of the earth. And then he researched, and um, he got into the experiments and done his research for the gravitation and for this force which things the pull toward itself. So he thought that earth must have some kind of force which through which it attract the things toward itself. So that was the Newton's law. That's how he got into this experiment and derived a law today which we called it as Newton's law of gravitation. Newton's law of gravitation. So what does it say? So it says every object attract every other object with a force. Okay, so every other object attracts every other object with the force which is directly proportional to the product of the masses. This is the same term which I have explained just here, which was this term. So the forces of the masses was directly proportional to the force was directly proportional to the masses of the product of this masses, which was m1 into m2, and it was inversely proportional to the square of distance between them. It means that force is also proportional to the force has its relation with the product of the masses, and it does also have the relation with the square of the I mean the distance in which they are kept apart. Okay, so this is very important if it can come for the definition perspective as well, but you have to include the definition and these two terms, plus you have to include the mathematical term. Write down just in the one word, that one line, that the mathematically this term can be expressed as, and write the mathematical expression which we just have studied. So I hope things are being clear to you. These are the easy and important concept. So I don't think that this chapter must be the difficult one for you. Okay. Similarly, what is the gravitational force? Whenever we are measuring the gravity or whenever we are measuring the gravity in terms of the force. Okay, so whenever we are measuring the gravity in terms of the force, it is called as gravitational force. It is called as gravitational force. So whenever there is the force of attraction between the bodies, between the two objects due to the gravitation. I mean, the force could be happen because of the anything. There could be the force exerted because of the many thing. Okay, but now when the force is there, force of attraction between two objects, and it is done because of the gravitation, it is then the force will be called as gravitation force. A very simple concept. Whenever there is a force of attraction, whenever the force has been exerted because of the gravitation, because of the gravity, that force will be called as gravitational force. Mathematically this can be written as F is equals to m1 into m2 upon r square. I hope this concept won't be the any something which is new or something which is hard to remember. Okay, where m1 and m2 are the masses of the two objects, and r is the distance between them. Please keep in mind this r doesn't stand for radius of the circle or radius of anything, but this is the distance which is there between the two objects which are being held together because of the gravitation. Okay. Yes, then moving on to the next point. Yes, the another concept related to the gravitation is circular motion and centripetal force. So, what does this terms means, and what is the concept behind this terms? So, we have already learned about the circular motion in your previous classes, in your previous standards. So circular motion, what does the motion means? What does the motion means? It's a very simple term. Whenever something moving, it is called as it can be defined as the motion. So, and when something is moving along the circular path, when something is following a circular path while it is moving, then this motion is called as circular motion. Please consider it to be as a circle. I hope you all can see it, but even if this doesn't seem like a circle, perfect circle. Okay, so whenever the object is moving along the circular path, it is tracing a circular line, then the motion of that object will be called as the circular motion. Okay, and the most important concept, centripetal force. I mean, if something is moving along to the circular path, then there must be something which keeps that object moving along the circular path. So what force is behind that? That force is nothing but the centripetal force. That force is nothing but the centripetal force. What does the centripetal force does? This is the force which is required, which is there whenever something is moving in the circular path. This force keeps the object attracted toward itself. Just in the similar case, as we have seen that sun is in the center, it it pulls the other planets toward itself. In the similar way, when the moon is traveling or the moon is tracing the circular path around the earth, and the earth exerts a gravitational force on the moon, I have written it down here as well. Whenever the planets revolving around the sun and moon revolving around the moon revolving around the earth, so this is the centripetal force, which the force which is exerted by the sun on the planets, which keep them moving along the circular path, along the circular path around the sun. So this force is called as centripetal force. Okay, now key point here is this is the centripetal force. So the force which is towards the center. Okay, the force which is which is directed toward the center is called as centripetal force. So this centripetal force is also called as center seeking force. Okay, this centripetal force is also called as center seeking force. And the opposite of this force, the opposite of centripetal force is centrifugal force, which is directed away from the center of the circle. But right now it is not the point which we must go into the details, because we are doing here the crash course and I want the topics to be covered which are most important. So we'll discuss it later, centrifugal force. But right now the important concept for you all is centripetal force. Okay, yes. Okay, so now moving on with the next topic, which is variation of G. While I'm talking about G, it is not the gravitational constant G, but I'm talking here about the small g. Okay, so variation of G. Variation of variation in the value of G. Again, it is not the gravitational constant wala G, but it is a small g, which is acceleration due to the gravity. Acceleration due to the gravity. According to the Newton's second law of motion, the gravitational force acting on the body results in the acceleration. According to the Newton's second law of motion, when I say that according to the Newton's law of motion, I'm not talking about the acceleration. I'm not talking about the gravitational force or the Newton's law of gravitation, but it is the Newton's law of motion. So the first law of motion was the anything will be in the rest of the uh, anything will be in the state of the rest or in the state of the motion unless and until it is exerted upon by the any external force. So that was the first law. And the second law, what does the second law? Second law says that anything upon which the force is being acted upon, then only the body will be accelerated. Okay, so according to the Newton's second law, the gravitational force acting on the body results in the acceleration. result in the acceleration. Thus, the gravitational force due to the earth acting on the body. Whenever some kind of force being acted upon the body or the object will show some changes. And when that change is being done because of the force which is exerted by the earth, whenever whenever this change is being done because of the force which is acted upon by the earth on any object, then this force will be called as the acceleration due to the gravity. Okay, acceleration due to the gravity. And this yes, so the earth exerted the force and the body has shown the acceleration. That's why this force or this acceleration which is caused by the gravity exerted by the earth, then this object and this force is called as acceleration due to the gravity. This force will be called as acceleration due to the gravity. I hope the concept is being clear to you. If you have any doubts, you can ask me in the comment boxes. Yes. Now, the value of g, acceleration, keep changes when it changes its position. I mean, the when we are checking the acceleration exerted by the earth on the surface along the earth, so it keeps on changing because as we know the fact that earth is not a perfect sphere, it is different in the different positions. So when we are checking the g along the surface of the earth, it does not remain same. It doesn't remain same. It changes along with the different position. So the shape of earth is not same everywhere. The shape of earth is not same everywhere, but the shape of earth is somewhat like it bulges at the pole. It's somewhat bulging. My drawing is not being perfect here, but I hope that um you guys can assume it as to be a sphere, which is this is earth. So it is bulging at the poles and it keeps flatten at the earth. Then again it keeps bulging at the another pole. I'm trying my best, guys. Okay, so this is bulging at the poles and flattens at the equator. So this is somewhat the shape of the Earth. So when we measure the acceleration due to the gravity at the different positions on the Earth, it keeps changing. Why it keeps changing? Because the Earth bulges at the equator and flattens at the poles. Okay. Sorry, I have written, it's my mistake. The earth bulges at the poles and not at the equator. The earth bulges at the poles and not at the equator. Let me just bulges at the equator, not bulges at the equator, but it bulges at the poles and not at the equator. And it flattens at the equator, not at the poles. Sorry, guys, my mistake, my bad. It Okay, so the value of G, which is highest at the poles, 9.83, 9.83. So the value of the acceleration due to the gravity, the value of G will be highest at the poles, will be highest here, which is 9.83. Sorry guys, what the hell I'm doing. Okay, so the value of G will be high at the point which is 9.83. And as we move down towards the pole, it will keep on changing. It will keep on decreasing till here. When we reach at the equator, it will be somewhat about 9.7. And nothing large or the drastic change will be seen here, but the difference in the positions or different in the digits after the decimal will be seen here. So the value of G will be the highest at the at the pole where the earth is bulging, and as we move down towards the equator, the value will change to the 9.7. And as again we move towards the poles of the earth, the value will again keeps on increasing, and it will be 9.8 again over the poles, over the poles, near the poles. Okay, now as we will changing with the heights, as we move away, it is very commonsensical concept that as we move away from the surface of the earth, the value of g will keep increasing. The value of g will keep decreasing, not increasing, because the center of the earth is the place where there is a center of attraction, where there is a center of mass, है ना? So as we keep moving away from the center of earth, the value of g will weaken. Okay, the value of g, gravitational force, will weaken, and the value of g decreases and not increases. Now it does also change as we move um, deeper into the earth. So one may think that as we move deeper into the earth, we are moving toward the center of the mass, or the core center of the earth, or core center of attraction. But as we go deeper into the earth, our g does not increases, but in contrast it decreases. And what makes that happen? Because as we move deeper into the earth, there is also something, there's also the let's see. Let me draw a circle over here, which is not a perfect circle, but assume it to be the circle. So when we are moving toward the inside of the earth, where there is the core of the earth, and here there is the more center of attraction. There is a more attraction and more gravitation. But there is also something here where there is a gravitation. Here's also the gravitation. These are all this also the surfaces where there is a gravitation. So when we go inside into the earth, when we are going inside into the earth, there also the force of gravitation from the surface of the earth, which pulls us toward itself. Okay, and the layers from the inside and the gravitational force which is coming from the outside cancels each other, and there will be nothing when we go deep inside the earth. And when we'll reach into the core of the earth, which is g, the value of g here will be 0. The value of g at the center of the earth will be 0. Okay, why does that happen? I have already told you, because the force of attraction from here and the force of attraction which was coming inside from the earth cancels each other, and that's why the value of g when we reach at the center of earth becomes 0. Okay, I hope this point is clear to you. Moving on to the next point. Okay, the most important and maybe the most easy concepts of the chapter. Moving on to the Kepler's law of orbit. Yes, Kepler's law of orbit. Kepler's law of orbit. So Johann Kepler was the first one who, maybe before the Sir Isaac Newton, who has given the planetary laws and the laws of orbit based upon the position of the planet and what force they are exerting and what force they are being experienced with. So Kepler's first law says every planet move around the sun in the elliptical orbit. Again, not in a perfect spherical orbit. We all know that planets move around the sun in the elliptical orbit, with the sun as its one of the focus, or at the foci. So whenever the sun is the sun, which is already in the center of the uh, center of the space, or the center of the solar system, so every planet revolves around it in the elliptical orbit, with the sun as its one of the focus. This is the first law, and this is a very easy law. Please go through it properly. And there are this the most probable topic which can come in the boards, and most of the time it has been asked even. And then the moving on to the Kepler's second law, what does it says? That lines joining to the planet and the sun sweeps the equal area in equal interval of time. By the way, this is Johann Kepler. Please appreciate my efforts. I have, um, what should I say? Okay, moving on to the Kepler's second law. The lines joining the planet and the sun sweeps equal area in equal interval of time. I think you should appreciate because I have made such a beautiful presentation, no? That's why. The joining, yes. So the second law says that the if let's say if the planet one is here, I'm talking about only the planet one. If the planet is here, this is somewhat at the far away distance from the sun. Okay, this is the far away distance from the sun. Let's say if it is covering the distance of point A to the point B, okay, point A to the point B. So let's say if it is covering this area or this distance in the point in a time, let's say X, then even if it is moving away from the sun and moving not moving away but covering this distance and moving towards here, with this is a position which is near to the sun. Here only it will cover the same distance, whatever distance it has covered here, this will cover the same distance over here, which is point from point A to B in the similar time, which was X. In the similar time, which was X. And the most basic reason behind this is that because the this planet was far away from the sun here, so it was moving with the slower speed, not faster speed but the slower speed. But when it came near towards the sun, it will start moving with the greater speed because it has been exerted by the gravitational force and more stronger gravitational force as compared to this position. So this makes the planet move with the more speed. So it will cover the same distance. है ना? The difference between this and this position is just that it is moving faster and this one is moving slower. But the similar thing is it is covering the same distance. It is covering this planet also has covered the same distance and that too in the same time. So this is only what the second laws implied, that line joining the planet and the sun sweeps equal area in equal interval of time. And the key points over here is the farthest distance from the sun is called as apogee, and whereas the shortest distance is called as the perigee. Okay. Okay. But Johann Kepler also have given this two laws, which tells us about the planetary the motions of the planet and the position of the planet and how they were revolving around the sun. He has also given us about told us about the positions and the the line or the path on which they were traveling. But what about the distance between the sun and the planet and the time which they has taken for the revolution? Okay, so he has given the third and most important law, which was law of period, which was law of period. So let's move on to that. So Kepler's third law. What does the Kepler's third law says? Kepler's third law says that the square of the time period of revolution of a planet around the sun. It means that whatever time the planet is taking to revolve around the sun and that to the square of that. Let's say if the time taken by the period to revolve around the sun is time t. Okay, the time taken by the sun to revolve around the time taken by the planet to revolve around the sun is time t. And here we are taking the square of that time period and that will be directly proportional to the cube of the main distance. It means whatever time it is taking to revolve around the sun will be directly proportional to the cube of mean distance between the sun and the planet, and that distance here is given by r. Okay, so whatever distance is there, it will be directly proportional to the square of the distance. It means what in which time the planet will cover the distance around the sun, that will be directly proportional, that will be equals to the distance cube of the distance which is there between the sun and the planet. And here again this proportionality, the sign of proportionality is replaced by the k constant when we transpose this r towards the denominator of this t square. Okay, so this was the law third. Okay. Now mass and weight. What does the mass means? So mass is the amount of matter present in object. So whatever things the any object occupies, whatever things it does have imbibe in itself, that things is the amount of matter which is there in the object. So this is nothing but the mass. Okay, that things which are there involved in that object, which indicates its capacity to hold things, this capacity or this amount of matter which is there present in the object, this is called as the mass of that object. That will be the mass of that object. The SI unit of the mass is kg. The mass is measured in the kg, and mass is a scalar quantity. Now again, this may be the concept which you haven't revised well, but you have to, because this is the important concept. What does the term scalar quantity means? Most of the students ignore this basic concept. But what does it mean? The scalar quantity, the quantity or the yes, the quantity which does have the magnitudes, but it is not related. It does not have the any direction. It does not have any relation with the directions. So that quantity will be called as the scalar quantity. And the most important points, its value will remain the same everywhere, even if I put the some object on the another planet, the mass of it, uh, s- it is the basic things that whatever things which will be there inside it, that thing will not change even if I change its position. Okay, so if I keep that thing over to the different places, its value does not change. Okay, so the value of mass will remain same everywhere. So according to the first law, measure of the inertia, higher the mass, higher the inertia. Whatever things will be there, if the thing is very much huge or heavy, so heavier force will be there. Heavier force, I'll require the heavier force to change its state of rest or the state of motion. So the same law is being given here, that higher the mass, higher the inertia will be required to change its state. Okay, so the things about mass, that it is the amount of matter which is there inside any object or the amount of matter present in the object. The SI unit of mass is kg. The mass is a scalar quantity. Its value remains same everywhere. So see guys, if this questions come in terms of differentiate between mass and weight, so you can keep it simple and short, but keep it precise. There are very short sentences or short difference in between the mass and the weight, and it is not much difficult. I guess it is very easy to remember. Okay, so its value remains same everywhere, and according to the Newton's first law, the measure of inertia in an object, higher the mass, higher the inertia. जितना ज्यादा mass heavy रहेगा, उतना ज्यादा inertia will be required to change the state, even if it is in the state of rest or in the state of motion. Okay, difference between the mass and weight. So now let's see about what does the weight is. What is the weight? So weight of an object is defined as the force. It is nothing as similar to the mass. This weight is defined as the force. Okay, so weight will be measured in terms of force. Okay, so weight will be termed in the measure of force with which the earth attracts the object toward itself. Okay, with which the earth attracts the object toward itself. Okay, so weight is not similar to the mass, but it is the force with which the earth attracts the object toward itself. Okay, so weight being force, it is written as force is equals to mass into the mg. Okay, force here, force which where we are measuring it in the terms of gravity, or the force with which the earth is attracting the things toward itself. So weight is equals to mass into the gravitation. How much force is applied in any object, it will be measured in terms of the product of the that mass and the gravity with which the earth is pulling things toward itself. Its SI unit is Newton. Also, weight is the vector quantity. Again, it is the difference, it is in contrast with the scalar quantity which has magnitude but it didn't have the direction, and the vector quantity which will have the magnitude and it will have the direction as well. Okay, so the weight is the vector quantity which is and this directed toward the center of the earth, which is directed. What kind of direction it will have? It will be directed toward the center of the earth. Okay, okay, so this was a simple concept. I hope this concept is being clear to you. Moving on to the next concept now, which is free fall. Which is free fall. What does the free fall means? When an object falls towards the earth only under the influence of gravitational force, it is said to be in the free fall. When an object falls toward the earth only under the influence of the gravitational force. I know that, and we all know that whenever something is falling toward the earth, or whenever something falling toward the surface of the earth, there are the certain things which are being applied on it, like there is the air resistance, there is a friction of the object, and there are much more things. Okay, there is atmospheric pressure. But whenever we are considering any concept in the physics, we have to avoid something or we have to ignore something. Similarly here, when we are learning about free fall, okay, so we have to ignore the other resistance like air friction or atmospheric pressure or the inertia of that object. But the free fall is whenever the object is falling, that object will have only one force, and that will be the gravitational force. No any other pressure or the force will be applying on that object. Okay, so when an object fall toward the earth under the influence of gravitational force, it is said to be in the free fall. It is said to be in the free fall. Okay, now key points. What will be the motion during the free fall? That speed continuously increases and object accelerates. Okay, whenever something is falling toward the center of earth, its speed will not change. Its speed will not change, that here it will be increasing, then here it will be decreasing. That won't happen. The speed will only in the increasing direction and will only increase and accelerate. So key points here are the that motion during the free fall, speed will continuously increase and object accelerates. And acceleration in the free fall, which is g, acceleration due to the gravity. The acceleration of the free falling in the free falling body is called as acceleration due to the gravity. Of course, the acceleration which is there in the body, it has done because of the gravitation. So we will take g here, and the value of that g will be 9.8 meter per second square. Now the example of the free fall are stone dropped from a height, and if the apple falling from a tree, the similar apple which has fallen down on the Sir Isaac Newton. Okay, so these are the some examples of the free fall. Okay, now if something is falling under the influence of gravitational force, that was a free fall. So its initial velocity will be u. Okay, the initial velocity which we measure in the terms of u, That will be zero. That will be zero. And why does that happen? Because whenever I'm dropping something and when I'm holding that object in my hand, the initial velocity will be zero, okay? And the acceleration which will be there due to the gravity, will consider it as g. So as there was a three equations which are there in terms of motion. Okay, so which were v is equals to u plus at and all that three terms. Here we are writing it in the terms of gravitation. Okay, here we are writing this that three terms in the terms of gravitation. The first one here is the velocity, which is related to the velocity and time. Okay, so we know that u here is zero. So when we are writing that v is equals to u plus at, so u is zero here. That's why we have written here that v is only equals to the g and t. It means the velocity will be equals to the product of the gravitational force, acceleration to the gravity, and the time. Okay, and distance. And if we are talking about the distance and time, so the time square, the time will be directly proportional here to the speed which will that object acquire with the time. So this is about distance and time, that s is equals to half of gt square. Similarly, with the velocity and distance, v square will be equals to twice of gravitational g and speed. Okay, v square will be equals to g and s. Okay. Okay, moving on with the next concept, which is escape velocity. Sorry, guys. Okay, moving on with the next concept, which is escape velocity. Okay. Escape velocity is the minimum velocity with which an object must be thrown or must be projected. So it can escape from the gravitational field of Earth without falling back. Okay. So what is the escape velocity? Whenever I'm throwing anything such that it should go out of the field of the gravitation, it should out of the reach of gravitational force, so that minimum force which I'll be requiring, that force will be called as escape velocity. So escape velocity is the minimum velocity with which object must be projected so that it can escape from the Earth's gravitational field without falling back. That object does not have to come back again to the surface of Earth, but it has to break that gravitational field and go out of the Earth's gravitational force. So that force will be called as escape velocity. That force will be escape velocity. Okay. So guys, I have completed all of the concepts here and it's a wrap. So here are again some important concept. So Earths attract every object towards itself because of the gravitational force. Okay, Earths attract every other object because of the gravitational force. Okay, so guys, it's a wrap. And again, here I have discussed, or let's just summarize the basic concept again, which we have done. The first one was the Earth's gravitation force, the force with which the Earth attract the things toward itself. That was the gravitational force. And center of mass of the Earth, it's situated at the center. This object fall down towards the on the Earth. the similar reason, which was the Isaac Newton was curious about. The answer is the center of mass, or the core center of attraction through which the earth attract the things toward itself, is situated at the center of the earth. That's why the most of the object fall downwards on the earth. Okay. And Newton's law of gravitation, what does it? Says that every object attract every other object with the force which is directly proportional to the masses of the object and inversely proportional to the square of distance between them. This is very, very, very important concept. I have explained it in detail, and also have given the mathematical term, okay, for it. So if this question is being asked in your paper, please write down this complete concepts about it. Write down the complete concept about it. Also, don't forget to write down the mathematical expression related to this, which was F is equals to G into M1 into M square M2 upon R square, where the M1 and M2 were the masses of the product of the masses, and and that m1 and m2 was the masses of the object, and r was the distance between them. So I hope all the concepts which were there in your chapter are being cleared here, and see you guys in the next video. Yes, it's done. So I hope you have enjoyed this and all the concepts are clear to you now. And if you have any doubts, please ask me in the comment box. Please like this video, comment on this, and subscribe my channel. And wait for the next chapter. I'm coming up with the different chapters. Okay, see you guys. Bye.